In Part 2, I introduced data flow and observations. Here, we'll take a quick look at how information moves through orientation. This diagram represents the initial phase of the data information flow that I used in Part 2, but in a biological perspective. It contains the unattended data, the unfocused peripheral information that enters covert attention, the focused information gathered through gaze control and foveal attention, the serial organization that feeds information from the optical to the perceptual systems, which brings us to the concept of orientation. Here, observations, which include hearing and touch, are fed into new information, our short-term memory or working knowledge. Serial information processing gives way to parallel processing, a much more powerful tool. This is shown by the two-way arrows that connect each component in orientation to the others. In an oversimplification, the current thinking in neurobiology is that there are two overlapping but distinct processes for decision-making and action. What is called System 1 are unconscious actions. Think of these as a learned reflex. In System 2, deliberation and reflection are used before an action can be initiated. What we have so far is a rough roadmap that information travels on its way from observations to actions. Now consider two factors in its journey, speed and quality. There should be no doubt that the speed of information flow between individuals will differ. Genetic, environmental, and experiential differences all play a role in how fast information results in actions. The quality of the information flow is also variable. Noise, distractions, ambiguity, the opponent, teammates, and other factors all contribute to corrupting the value of information. We'll deal with this later when we consider the effects of friction. I'll end this video by setting up a hierarchy of data and information, what we have in the system so far. Raw data exists, but it escapes notice. For our purposes, it's unobserved or ignored. Processed data has been noticed by the observation system. It has potential meaning and enters short-term working memory. Information is processed data that has significant meaning. It appears as interesting, novel, or an anomaly. It's data that holds attention. Processed information is what we act upon. It has perceived value and usefulness to a task. In Part 4, I talked about targets being dynamic, nested, and hierarchical. The same framework applies to information in orientation. Information is in constant flow, so it's dynamic. It can be broken down or combined with other bits of information to create new information, so it's nested. And each bit has value relative to the others and the environment, so they're hierarchical. Since targets are out there and information is in there, and players need to find a match between these two, it would appear to be easier to match smoke rings. This is the problem that Boyd faced and found a solution for.